Welcome to EDU World Space.
Here to find out the angle of deviation for violet and red color light, first of all we should know certain initial concepts of refraction, Snell's law, then what we mean by angle of deviation. So if you look at to this particular figure, then let me explain you. Here you see this is an incident ray we have on this spherical drop, which makes an angle of incidence theta 1, let's say, and when it enter into this denser medium of certain refractive index, then instead of traveling in straight line path, it bends towards this normal, so it will travel from A to B like this. And when it incident on other side of the spherical drop, so here it should actually travel in straight line, but as it travels from denser to rarer, so it bends away from the normal by making certain greater angle. So at this particular surface there the refraction takes place, and for this refraction we can use Snell's law, which actually says that the sign of angle of incidence is directly proportional to sign of angle of refraction for a particular pair of mediums. Now here we have given the refractive index of this medium for violet color, which is 1.341. Then a refractive index for a red color is provided to us, which is 1.330. For different wavelength, this medium has different refractive index. So definitely the angle of refraction that would be also different. Let us first of all use the Snell's law for violet color light. So by Snell's law, I can write here the refractive index of air, in which the angle of incidence is theta 1. So Na sine theta 1, that would be equal to here the refractive index for violet color in this particular medium into sine of its angle of refraction. As you see there, it is theta 2. So let's say this is equation number 1. Similarly, for violet color, we can use this Snell's law at this second at the emergence path. So when we use Snell's law for second refracting path, then we can say it is refractive index of air into sine of theta 4, which is actually here we have angle made with the normal by emergent ray, that is equal to refractive index for violet in this medium. So in the medium of this spherical drop we have its angle of incidence, which is theta 3. So let's say this is equation number 2. So these are the two equations that we are written for this violet color light. Now if you see here, if by extending this normal at the center, okay, so in triangle AOB, as the side AO is equal to OB, which are nothing but the radius of this spherical drop. So as these two sides are equal, so their opposite angles, that is theta 2, that should be equal to theta. And if this data we put up in this equation, then we can write NA sine theta 1, that is equal to NV sine theta 3. And let us say this is equation number. If we compare equation 2 and 3, their right hand sides are same, so I can equate their left hand sides. So Na sine of theta 4 is equal to Na sine of theta 1. So as these are refractive index of air, will be get cancelled, and on both sides if you take sine inverse, we get theta 4, that is equal to theta 1. So from this particular result, what we conclude, that angle of incidence at one surface, that is equal to, here we have this angle of emergence, that is theta 4, and those are independent of refractive index. Now the angle of deviation, that means the angle by which this incident ray is get deviated from its original path. So let's say this is phi 1, here we have, and should travel in this particular path like this, but because of change in medium it travels in this direction. It means it get deviated by this much angle. So let's say this is phi. So from the geometry of this figure, this angle of deviation for violet color light, that would be equal to, we have angle of deviation at first surface plus angle of deviation producing second refraction. So this would be equal to, here you see this angle of incidence is given to us, that is 60 degree. So this phi 1 should be 60 minus this theta 2 plus phi 2, that should be equal to this theta 4 minus theta 3. Now as theta 2 and theta 3 are same and this theta 4 is equal to theta 1, so if I plug in those values, that would be 60 minus theta 2 plus this theta 4 is same as that of angle of incidence, so it is 60 minus theta 2, I'll say. So 60 plus 60, that gives me 120 minus theta 2, that would be minus 2 theta 2. So this is what I have, the angle of deviation for violet color. Now as here it is given this angle of incidence, the refractive index for violet color. So from this two we can able to find out theta 2, as theta 2 would be equal to sine inverse of sine of angle of incidence, that is theta 1, divided by refractive index of violet color. And if I use the values given to us, then I will get this as sine inverse of sine of 60 degree divided by 1.341 for violet. Simplifying this, I will get the value of theta 2, that is equal to 40.22 degree. And this value of theta 2, if I put over here, I'll get the angle of deviation for violet, that is equal to 120 minus 2 times 40.22. So simplifying this, I'll get the angle of deviation for violet color, that is equal to 39.56 degree. Now similar to this, we can find the angle of deviation for red color, which would be also equal to angle of deviation at first surface for red color plus angle of deviation for red at second emergent surface. So this will be equal to, again I can write 120 minus 2 times theta 2, and for red color the theta 2, that I can again find by using Snell's law as sine inverse of sine of angle of incidence, that is theta 1, divided by a refractive index for red color we have given, it is 1.330. Simplifying this, I'll get this theta 2 here, that is 40.62 degree. And this value, when I keep it over here, I will get the angle of deviation, total angle of deviation for red color, that is equal to 120 minus 2 times 40.62. And if I simplify this, the angle of deviation for red color, that I will get here, which is 38.76 degree. These are what I have, the angle of deviation for violet and angle of deviation for red. Now we are asked here to find out the change in angle of deviation for red and violet. So just let me subtract these two values of angle of deviation of violet and red. So plugging their values in this relation, that is 39.56 minus 38.76, I will get the answer, that is 0.8 degree. So this is what we have, the difference in angle of deviation for violet and red when they are incident and emerge from the surface of spherical drop. Thank you.